Welcome to this lesson. So I told you that we'll be looking at the pseudocode of the MiniMax algorithm in this particular lesson. So let's look at that. So the pseudocode of our MiniMax algorithm. So this is how it looks. So these above lines are actually self-explanatory when you consider the explanations that I've given before. So this MiniMax of S, where S is the state of our game. That is the current state of our game. I already told you that, right? So first of all, it'll run the terminal function, which is the terminal function that we talked about earlier. This terminal test will determine if the game is over or not. If it's over, it'll send the utility of the current state, that it'll send the utility of the player who played the last state back. Okay? So that's stored in utility of S. So for this particular current state, this is the utility. This particular player wins, that is, it's either plus 10 or minus 10 or 0. So if it's not the terminal state, that's when you need to apply the actual MiniMax functions. The second line in the algorithm is for when the player of the current state S is the max player. You know who the max player is based on the game tree, am I right? So if the player is max, then it'll go through all the actions, all these actions. A belongs to action of S. Right, so it will go through all the actions that are available for the current state of the board, that is represented by the actions of S list. So it will create an actions of S list based on the current state of the board, and then it will go through all the actions where every A is every single action. So for every single action, it will call the MiniMax function again. Okay, it'll run the MiniMax algorithm again for every single action it's gonna run through the action of S list. Okay. So if the action of S list has 5 different actions, then this MiniMax algorithm will run another 5 times. And in here, inside it, it'll send the result of S, A value. Okay? So it'll run the MiniMax function multiple times. For example, let's say we have 5 empty spaces on our tic-tac-toe board. Then we'll feed that state to the MiniMax function again. We'll create a new game tree, and then we'll run the function again. That is, we're going to send everything back to MiniMax of S. Now again, it'll first check if there's a terminal, and if it's terminal, it'll store the utility of S value. If it's not terminal, then it's going to check if the player is max or min. So if the last player was max, this player is probably going to be min. And then it's again going to create a list of actions that it can perform right now. And then for all of those actions, it's again going to call the MiniMax with the result, that is with the next state. It's going to call the MiniMax with the result of the action. That is with what the state is going to be next if this particular action was executed. Okay. Finally, all the actions will be exhausted. And do you see the result of S, A in here? Once we reach the terminal state and get the utility for the current run of the MiniMax function, that utility value will be stored, and that will be the result of the MiniMax. So wherever we get the utility as positive or a win for the max player, we'll trace back that tree and ask the player to make that move. So this is what this line of code represents. So the same thing will happen if the player was the min player as well. So this might have been a little confusing, or maybe a lot confusing. So let me explain all of this again with the tree I drew before. So now once I explain it with the tree, you'll understand what the code actually means. Okay, in this diagram, we are running the MiniMax function with the current state of the board. So this is the current state of the board. Okay, so whatever the current state of the board was, we're creating a game tree based on that state. So we call the MiniMax of X on this particular state. It draws the game tree with the current state of the board and the actions that it can perform in this particular current state. So these actions are represented in the branches of our tree. So final utilities, that is for this particular state, these are the 2 actions it can perform. And then after this action is performed, these are the 2 actions it can perform. And similarly, that's how. For the first one, the actions of S will have this and this in its list. And after that, it'll call the MiniMax again for this. And for this, for the min player, again, we'll have our actions list which has both of these. And that's how it keeps going. That's why it's called a recurring function, because it keeps calling itself again and again. Okay, in here, this particular function, the minimax function, gets called again and again. So it calls itself. It calls itself until it reaches the final value, which is utility of s. So that's why it's called a recurring function, because it reoccurs. Okay, so in here, the final utilities are also mentioned in this tree. Do you see here the final utilities of the leaf trees? So the first action is the left tree. We make that. So now the player is the min player. We run the third line of the pseudocode. The third line of the pseudocode is this particular pseudocode because the player is min. So we run that line now because the other two statements return false right now. It asks us to get the next set of actions. So we are getting the next set of actions, which in our case for this it's these two. So we are getting the next set of actions, and it calls a minimax function again. So now the new tree will only have 5 different nodes, right? So this particular function will again call the minimax function. So this will become the new game tree. So that's how it keeps happening. So we call the minimax function again for the first action, that is the left node. This particular first action, which is the left node. Now it's a max player's turn. So the second line of code is run if the player is actually max. Okay, so when a second line of code is run, it asks us to run the minimax function with the current state, which is now only 3 nodes. So now this will be our game tree. Okay, so our second line of code, this line of code will again ask us to run another minimax function, that is create another game tree, and that game tree will have the actions. And now in this case, the action list is only this and this. So this will be the new game tree because this is the current. Okay. So now the minimax function is run again where the max player has chosen the left node. Okay, let's see. So now this node was chosen by the max player. So now what happens? Now it's reached the terminal state. There are no more branches in here. So the terminal test is true right now. So if the terminal test is true, it's going to take our utility. So in here, if the terminal test was true, it's going to take utility, and the utility in here is +1. So that's it. We've encountered our first +1. So it'll send the result back through the loop. And it'll have to wait for the next one. Okay? It'll send it to the previous state, but remember that the previous state had one more action left. So this will be sent to the previous state, but now the previous state is still pending because it needs 2 actions. I need to verify 2 actions before it calculates a utility for it, right? So now it will call the remaining action, this particular action, that is the right node, with the same minimax of s function. So this time again the utility is calculated because the terminal test is again going to be true. So now the utility is calculated as -1. So both the results are now, so both +1 and -1 are actually right now inside this. So it will be like +1 compared to -1. So now what we do is, if the player is a max, we'll choose the +1. If it was a min, we'd have chosen the -1. Since the player is max in this case, we choose +1 and that node is filled. As you can see, that's what happened here. Now the program will move back up the tree, because the min player has another action left. That is the right action left. That is the right move in the tree. So that action will be sent to the minimax function again. So the player is max. We're going to create another tree with just these 3. And these 2 are the action states. And again, we're going to run the minimax for each of these. And then we're going to find the utilities. And then again, we're going to go here. That is compare and then get our value, and then go here and choose +1. So finally the min player here will have 2 result values to choose from, and it'll choose the minimum value since it's the min player, obviously. So but since both of these are +1, it'll have to choose +1 by default. So now it'll go up the tree, another state up the tree. That is the first state of the max player. And the next action of the max player will be used to call the minimax function again. That is the right side of the node. That is the next action in its list. The next action in the root nodes list. So then we'll go through the right side and we'll get the final utility values for all of those 2, and then we'll fill up the results array, and then finally the results array will have a +1 and a -1 for the root node, for which the max player, since this is the max player is obviously going to choose +1 out of it. So it chooses the left side. That is the left action. So it will choose the action that is represented by this particular node. Okay, so if this particular node represents that the player has to draw on the fifth box of the tic-tac-toe board, then that's the action that it's going to take. Okay, so this means that the max player needs to move to the left node next to get the optimal result. That's the next optimal move if the AI wants to win. So that's how the algorithm works, and that's how we use our minimax function and a very interesting concept called recurring to solve a very important problem, that is, which is the next optimal move. So that's it for this particular lesson. I'll see you in the next one. Thank you.